Okay, working example number 3, model and solve a problem. So games are on sale for $12.50 and that includes tax. Sean has $80. How many games can he buy? That's our scenario. That's the situation we're faced with. Let's use the math that we've just learned to figure this out. So write an inequality to model the problem. Let n equal the number of games Sean can buy. And the cost of n games then becomes 12.5 times n. And we know that Sean can spend no more than $80. So the inequality to model this problem is that 12.5 times n, so that's the cost of the games, must be less than or equal to $80. So we can now solve the inequality and see how many games he can buy. So 12.5 times n is less than or equal to 80. We can divide both sides by 12.5 to get n by itself. We're going to isolate n. So 12.5 divided by 12.5 becomes just n. And then 80 divided by 12.5 is actually equal to 6.4. So n is less than or equal to 6.4. So how many games can he buy? Can he buy 6.4 games? No, you can't buy a partial game. So his options would be to buy 6 games or to buy 7 games. Well, the inequality says that it has to be less than or equal to 6.4. 7 wouldn't qualify for that. 7 would be more than 6.4, so he wouldn't have enough money. So it needs to be 6 games. He can buy up to and including 6 games for less than $80. So he won't spend all of his money, but that's okay. So that's how this works. And using estimation here, 12 games or 6 games at $12 each would be $72. 7 games at $12 each would be $84. So that shows approximately what you're faced with. 7 games would be too much. 6, he's fine. Now, there's one last show you know for section 2 of this chapter. Please go ahead and finish that up.